Have you ever tried carrying your backpack up a flight of stairs? You reach the top, drop it on the floor and think, phew, that was hard work. Well, guess what? In science, we can actually measure how much work you just did, and even how much power you used doing it. Today we're going to break down the science of work, power, and energy. And trust me, this stuff powers everything. Let's go. Let's start with work, but not homework. In physics, work means using force to move something over a distance. So if you push a box and it moves, you're doing work. If you push and it doesn't move, sorry, no work. Even if it feels like it. Here's the formula. Work equals sine force x distance. That means, the more force you use or the farther you move the object, the more work you're doing. Real life example. Lifting a heavy bag of groceries into the car, that's work. Just standing there holding it, technically no work, no movement. Now let's talk about power. Power is how fast work gets done. Same task, different speed equals sign, different power. Power equals sign, work time. Two people lift the same box, but one does it faster. They both did the same work, but the faster person used more power. That's why cars and engines are measured in horsepower. It's all about how quickly they can do work. So next time you race up the stairs while your friend strolls, you used more power. Now the real star of the show, energy. Energy is the ability to do work. It's what lets things move, heat up, light up, or power up. Energy can't be touched, but we can see and feel its effects everywhere. And it comes in lots of different forms. Let's meet them. 1. Kinetic energy. This is the energy of motion. Anything moving has kinetic energy. Cars, wind, a rolling soccer ball, even you running. 2. Potential energy. This is stored energy, just waiting to be used. Think of a stretched rubber band, a rock at the edge of a cliff, or water held up in a dam. If kinetic energy is running, potential is standing at the edge, ready to go. 3. Mechanical energy. This is the total energy of motion and position. It's the combo of kinetic plus potential. Machines use this to move stuff, gears, levers, engines. 4. Chemical energy. This is stored in things like food, batteries, and fuel. Your body breaks down food to release energy, yum and science. Gasoline, coal, and even your lunch all store chemical energy. 5. Thermal energy. This is heat energy, caused by particles moving around. The faster they move, the hotter something gets. Boiling water, hot soup, a warm blanket, they all have thermal energy. 6. Electrical energy. This comes from the movement of electrons. It powers your lights, phone, computer, and pretty much your entire life. 7. Nuclear energy. This comes from the center of atoms. It's what powers the sun, and nuclear power plants here on Earth. All of these are different forms, but they all do work in some way. But here's something amazing. Energy can't be created or destroyed. It can only change from one form to another. This is called the law of conservation of energy. Think of it like a shapeshifter. The total amount of energy stays the same. It just moves and transforms. A ball at the top of a hill has potential energy. As it rolls down, that energy becomes kinetic. When it hits the ground, it may turn into sound, heat, or even mechanical energy. The energy isn't lost. It just changes form. That's how cars turn chemical energy into motion. Power plants turn nuclear or chemical energy into electrical. Your body turns food into movement and heat. Every second of every day, energy is changing forms all around you and inside you. Let's recap. Work equals sign using force to move something. Power equals sign how fast you do the work. Energy equals sign the ability to do work. There are many forms of energy: motion, heat, sound, light, and more. And energy is never lost, just transformed. Here's your energy challenge. Look around you right now. Can you find one object that's using kinetic energy? One that has potential energy? Something that's producing thermal, electrical, or chemical energy? Make a list or draw a diagram and share your answers in the comments. Even better, try to follow energy through a system. Where does it start? How does it change? That's real science in action. And don't forget to like, subscribe, and turn on the bell, because next time we're diving into the world of energy transformations and how roller coasters, toasters, and you all run on science. Until then, keep exploring, keep asking questions, and remember, you don't need superpowers to feel powerful. You just need energy. End screen with subscribe prompts and related video suggestions.